Hello students, welcome to the lecture 5 for this week. In this lecture, we're going to talk about absolute value. And you're probably familiar with absolute value, but we would rather have a precise mathematical definition for the absolute value. So let's start with the definition and then we'll do examples. The absolute value and some people call it also magnitude of a real number, let's call it A, is denoted by, and you're already familiar with this, by two vertical lines and is defined by the following equation. We'll define an absolute value as a formula because it will make our life a little bit easier this semester. So we're going to call an absolute value of A to be A if A is greater or equal than 0. And we're going to call it negative A if A is less than 0. Alright, so this is a straightforward definition, a little bit unusual at first, but then when you get used to it, it will work nicely. So let's do a few examples to understand how it works. The first example we're going to do is we'll calculate an absolute value of 3 by using the definition. So let's look at number 3 inside of the absolute value. This number 3 is greater than 0, so that means we're going to use the top part of the definition. So we're just going to say that it's equal to 3. In our second example, we'll try to calculate an absolute value of negative 3 over 5. So we see that the number inside of the absolute value is negative. So when the number is negative, we have to put an extra minus. So let's try to do that. So we put the minus, we put negative 3 over 5, and minus gives us a plus. So we get a positive 3 over 5 as our answer. So that's how absolute value works in practice. The only thing that we might worry about, what would be an absolute value of 0. So let's look where 0 would fall in. Definitely we cannot put it over here because 0 is not less than 0, right? 0 is equal to 0. So that means we're going to use this part, and so it's going to be 0. So relatively straightforward. Big consequences from this rule. Let's look at one consequence of this rule. What if we think about square root of 16? So we know square root of 16 should be 4, right? Should be 4. Because 4 squared is 16. So the next question that we should ask is, if square root of a squared is equal to a? Question mark. Is that true? So let's try to look at the small example inside of this example, right? Small example would be, what would be the square root of negative 4 squared? Negative 4 squared. So negative 4 squared is 16. So we write square root of 16, and square root of 16 is equal to 4. But look, our original number inside, our number a was negative 4, and 4 definitely is not equal to negative 4. So going back to this question, how can we fix this? How can we fix it? So if we would have negative 4 over here at the end as our answer, we can make it into a positive number by putting an absolute value. So using this idea, we can create the following rule. So the rule, and in mathematics rule are called theorems usually. So let's create a rule. So we'll say that for any real number a, we have square root of a squared equal to the absolute value of a, and this would be the rule. All right, so we talked about this theorem. Next rule that is important and consists of few different parts. This theorem has the following. So part A of this theorem says that if you take a number a, it's always going to be greater or equal than negative. Didn't put it right. Let me fix it. It's going to be greater or equal than absolute value of a with a minus in front of it, and it's always going to be less or equal than absolute value of a itself. The part B of the theorem says that if you take an absolute value of a times b, it's going to be equal to the absolute value of a times the absolute value of b. And in part C of the theorem, we have that a divided by c with an absolute value is the absolute value of a over the absolute value of c, and definitely we can't divide by 0, so it should exclude 0 from consideration. And the last part, D, is kind of follows from rule B. It's very similar rule to rule B. It says that if you take a to the power n and have an absolute value, it's the same as taking an absolute value of a and raise it to the power n. All right, so one rule. We'll try to prove a lot of theorems in this course, so this would be our first proof of the semester, proof of part A. So what do we want to prove here? We want to prove that a is greater or equal than absolute value of a with the minus, and less or equal than absolute value of a. And when you deal with absolute values, the usually proof goes by cases, right? So we have case when a is greater or equal than 0. Where do we get this from? We get this from the definition of absolute value. That's where it splits up into parts. So what happens if a is greater or equal than 0? So in this case, we have a, and if a is a positive number, or equal to 0, you can definitely put a minus in front of it, and it's going to be smaller than a. Like if you have number 5, 5 is always greater or equal than negative 5. Okay, and also we know from the definition of the absolute value, again, the definition says that absolute value of a is equal to a if a is greater or equal than 0, and equals to the negative a if a is less than 0. We have the case when a is greater or equal than 0, so this a therefore is equal to the absolute value of a. So if it's equal to the absolute value of a from the definition of less or equal sign, it's less or equal than absolute value of a. All right. So the last step is we also know that a is equal to the absolute value of a. So we can rewrite this over here and saying minus absolute value of a less or equal than a less or equal than absolute value of a. Again, we substituted a with absolute value of a. So we proved this case for the a greater or equal than 0. Now we have to prove the case when a is strictly less than 0. So let's start with a, which is a negative number. So if you have like -7 and you put a minus in front of it, you're going to get a +7. So that means that means what? That means the following. So if we have a negative a is equal to the absolute value of a. So a is equal to minus absolute value of a. All right. And from this, we get that an absolute value of a is also greater or equal than 0. So in this case, we have a greater or equal than negative absolute value of a. Since it's equal to it, it's also greater or equal than it. And on the right side, if we put absolute value of a, is going to be true. So we proved this result. So let's solve an equation with absolute value sign. So let's solve an equation. So equations with absolute value. So I would like to solve an equation. So first example we're going to do is absolute value of x minus 3. X minus 3 is equal to 4. So what is the problem with absolute values? That we almost always have to consider few cases. Suppose the inside of the absolute value is greater or equal than 0. This would be our first case. X minus 3 is greater or equal than 0. And this would imply what? This would imply that if you take an absolute value of x minus 3, since the inside is greater or equal than 0, I just wrote the definition a little bit before us. So if the inside is greater or equal than 0, then the absolute value is equal to its inside. So we would have x minus 3. And from the equation, we get that x minus 3 is equal to 4. So this is the equation we're going to solve for this case. So we have x minus 3 is equal to 4. We add 3 to both sides, so we get x equal to 7. That's our first solution. But unfortunately, we have to also solve the second case when x minus 3 is strictly less than 0. So this would imply that absolute value of x minus 3 is equal to negative x minus 3, and from the equation we set it equal to 4. And so this is the equation that we need to solve. So let's distribute the minus through the expression. So we multiply -1 by x, we're going to get negative x. We multiply -1 by -3, we're going to get +3. And this is a crucial step to get this plus over here. And it's going to be equal to 4. So then we're going to subtract 3 from both sides to get that negative x is equal to 1. And if we divide both sides by -1, on the left side we're going to get, this would imply that x equals to -1. So we have two solutions. One solution is x equal to -1 or x equal to +7. So we have two different solutions. So that's how usually equations with absolute values work. You have to consider a couple of different cases. So also we might have inequalities with absolute values. So let's solve a couple of examples to see how it works in practice. The first example we get is x minus 1 is less than 7. So one more time, we have a couple of different cases. So one case is x minus 1 is greater or equal than 0. And this would imply that absolute value of x minus 1 is equal to x minus 1. And we set it less than 7 from here. All right, so we need to solve this inequality. X minus 1 is less than 7. So we're going to add 1 to both sides. And this will give us that x is less than 8. All right, so graphically we have 8 over here on the right. And everything on the left side of 8 would work. Everything on the left side of 8 would work. So that means any number less than 8 would work for this inequality. And except that we have to think that x is greater or equal than 1. X is greater or equal than 1. So basically, I have to add this piece to my answer. So I'll use the red color for this. So I have to start actually at 1, right? Including 1 itself, it would work. But we can't move past 1 on the left side because that was our condition for x minus 1 to be greater or equal than 0. So we go back to case number 2 where x minus 1 is strictly less than 0. So in this case, x has to be less than 1. So this is the case we're in. So let's think what happens with absolute value when x minus 1 is less than 0. It's going to be minus x minus 1. And we also set it less than 7. So we have minus x and we have plus 1 less than 7. So what we're going to do, we're going to subtract 1 from both sides. So we're going to get negative x is less than 6. And we're going to multiply both sides by negative 1. But when we do that, we have to reverse the sign. So x has to be greater than negative 6. So what kind of picture we're going to get in this case? In this case, we're going to start at negative 6 over here on the left. Negative 6. And we're going to go all the way to positive 1. All the way to positive 1, which is also excluded from the consideration. But now we have to combine those answers together. Either one of this solution works, this one or this one, right? So let's try to put them together. So definitely on the right side we have empty circle for 8. And on the left side we have an empty circle for 6. In the middle we have empty circle for 1 over here. But if we move up, this is negative 6, sorry. If we move up and look over here, we have to fill it in from the first part. So actually, it was empty from the second part, but first part fills it in. And so our solution will go all the way from minus 6 to positive 8, right? So x has to be between minus 6 and 8. This is an inequality answer. Then interval notation will be what? Interval notation would be from minus 6 to 8 with parentheses. And in set builder notation will take all x's such that x is bigger than negative 6 and smaller than 8. And this concludes this complicated exercise. So let's see one more exercise for this question. So another example that we're going to do, did I give the name? Let's say example 1, and this will be example 2. Example 2. So what would be the example 2? Let's think we want to solve this inequality. X plus 4 is greater than 2. So again, cases, right? So case when x plus 4 is greater or equal than 0. This implies x is greater or equal if we subtract 4 from both sides. We're going to get x is greater or equal than negative 4. All right, so let's look at the inequality. We have x plus 4, which is just x plus 4, since x plus 4 is greater or equal than 0. And we have to set it greater than 2. So what we're going to do, we're going to subtract 4 from both sides. Subtract 4 from both sides. And if we subtract 4 from both sides, we'll get that x is greater than 2. X is greater than 2. I said 2 actually. That is negative 2. X is greater than negative 2. All right, so let's try to pull all of this together. So we have line going this way, and so line going this way, and we start at negative 4 on the left, so we put a filled-in circle at negative 4, but then to the right of negative 4 we have a negative 2 over here. So we would like this to be true, otherwise our inequality will be wrong, right? So this definitely has to be true. So we cannot take any values between negative 4 and negative 2, otherwise this inequality will not work. So that means we want to take all of the answers to the right side of negative 2, right? Because this has to happen at the same time. And at the same time means intersection. So basically we want to take where those two intervals from negative 4 to positive infinity and from negative 2 to positive infinity intersect. And they intersect exactly in this region, starting at negative 2 to positive infinity. All right, so this was this hard case. So now this second case is x plus 4 is less than 0. So this, if we subtract 4 from both sides, means x is less than negative 4. So x has to be less than negative 4, then our absolute value becomes negative x plus 4 less than, sorry, I said less than, but it's incorrect, greater than 2, greater than 2. So we distribute the minus through the expression, so we're going to get negative x, then minus 1 times 4 is negative 4, and it's strictly greater than 2. So we add 4 to both sides, and we get that negative x is greater than 6. And if we multiply both sides by negative 1, we're going to get x is less than negative 6. X is less than negative 6. That's our answer. Why we reverse the inequality? Because we multiplied by a negative number. So again, this expression x less than negative 4 should be true at the same time as x is less than negative 6. And again means intersection. So let's start. So where is x is equal to negative 4 is over here. We use an empty circle since it's a strict inequality, and it has to go all the way to the left. Then we take an empty circle for -6. Oh, maybe different color. This is -6 with an empty circle. And we want to take everything that goes all the way to the left. And we see where the black curly line intersects with the red curly line. And they intersect in this region from -6 to -infinity. So our answer will be x less than -6. Finally, we put all these answers together. One solution is from -6 all the way to -infinity. And this is from here. And from the first answer, x is greater than -2 comes down over here. So, oh, not here, a little bit lower, sorry. Comes down over here, so 2 all the way to +infinity. All right, but we write our answers always from left to right. So write answers from left to right. This is a exclamation point, and another exclamation point. So very important. So let's try to write our answer. So we want to take the region from -infinity to -6. All right, so this would write -infinity, -6, or the interval from 2 to +infinity. Again, we're moving from left to right. But unfortunately, for the symbol or, we have to use the cup symbol. This means union of two intervals. Right? We discussed it a little bit before when we talk about sets, union of two sets, right? So answer will be written answer in interval notation. Interval notation will be from -infinity to -6, union 2 to infinity. I said +2, but was it -2? Yeah, it was -2, sorry. Minus, sorry. It's a little bit of a mistake, but we fixed it. And also we need set builder notation. In set builder notation, again, in the questions in the homework, you only will be asked for one type. Set builder notation would be all x such that x is smaller than -6, or x is bigger than -2. All right, so we talked about this hard examples, and to finish our lecture, one important rule that might be helpful in the future is called triangle inequality. And triangle inequality says the following, that if you take an absolute value of a plus b, it's always less or equal than absolute value of a plus the absolute value of b. All right, so a couple of rules to memorize, a couple of examples that we did. So probably a good place to stop discussion about absolute values. And I'll see you in the next video.